Hello friends, welcome to this new video, and this video is special because the topic which I am covering today has been suggested by one of our subscriber Vinay, who wanted to understand what is a data vault. So thank you Vinay for your suggestion, and guys, if you have not yet subscribed, please go and subscribe the channel to get such good content and understand it in a very easy way, and also hit the bell icon and press the like. So let's get started and understand what exactly is a data vault and how it is different from a third normal form and a dimensional model. So before we start and before even we go and touch data vault, there are some concepts which we have to refresh before we jump onto this data vault technique or data vault modeling concept. So first of all, let's understand what is a third normal form and what is a dimensional model. So I think most of you are aware of what is a data warehouse. Still, we'll quickly understand what is a data warehouse. So data warehouse is a central repository or a central reservoir where all the disparate source systems of an enterprise company or an enterprise comes and stores data, and that data resides there forever, and then there is history which is maintained on top of it. All the data comes and just gets stored into that data warehouse or a data lake, and then business can perform analytics, business can perform operational reporting, business can derive value out of that data. Let us understand why we have these two main modeling techniques and why these were and these are still very prominent when it comes to designing a data warehouse. Third normal form is a modeling technique which is a very common technique when it comes to an operational system. When I say operational system, so every company has the businesses running throughout its enterprise, and all those business processes stores data into some sort of a database. So take for example, you go to a grocery shop or you go to a retail shop and you pay something at point of sales and purchase an item. So all that process and all that workflow gets recorded into some database in a company, and that database is designed mostly in a third normal form. So in a third normal form, we have data highly normalized. So we have tables linked in a way wherein we have multiple joins, we have data to the lowest grain possible, so that it makes writing the data into the database faster. Why it is so? Because in order to run business processes efficiently, your data should be tuned for faster writes. On the flip side, a dimensional model has a different objective. So a dimensional model is aimed at providing business value to the business consumers and the business users who want to understand what is exactly happening in their enterprise and how they can derive value from that data. That's why the data model which is designed for that specific purpose is called a dimensional model, wherein you derive the dimensions and the facts and then you model it in such a way where the reads are fast. So in a third normal form, you can write faster. In a dimensional model, you can read faster, and also the data model provides a very good context, business context to the business users. So over the period of time, these were the two main theories or two main pillars which were introduced by two fathers of data warehousing. 3NF, third normal form, or we can also call it as an entity relationship approach. This particular approach was coined by Bill Inman, and the dimensional model, this approach was coined by Ralph Kimball. So while designing the data warehouse, these two were always prominent, but there were some challenges. There are some challenges which we have to understand. With the pace at which the data is growing, with the pace at which the business is growing, the business processes are evolving, you have to be very agile when it comes to your data warehouse. You cannot have a data model which is rigid, which cannot grow quickly, which cannot adapt to the changes quickly, and that is where there was a gap, and that gap was fulfilled by data vault. Data vault is a concept which was coined by Mr. Dan Linstead, and he understood the gap which was produced by the rigidity of a 3NF data warehousing technique and a dimensional model, and he came up with an hybrid approach which took the good things of a 3NF and the good things of a dimensional model, and then it provided the kind of agility and the flexibility which was missing. So let's understand this concept through a business workflow, through an example, understand the challenges, and then we will understand how Data Vault comes into the picture and how it tries to resolve these challenges. Suppose this is a data model made for a rental property data model. So it shows you the business process flow for a property which is rented, and the details are linked with different tables. So you have your owner which owns the property at a certain location. That property is rented to a tenant, and then that tenant has his own details, and owner also has his own details. So it is a small data model which I have built. So if we talk about 3NF, third normal form, so this is something how it would look in a third normal form. It would be highly normalized. Now what challenges you have in third normal form? Every table will have its own primary key, but again with that you will also have the date timestamp attached to it, because in order to understand the uniqueness of a record, you have to attach it, and you have to avoid duplicates in a third normal form. So that's why you will always have your primary key plus your date timestamp. So now understand that because of the way third normal form behaves, suppose if there are parent-child relationship in a data model, then every change happening at the parent has to be cascaded to multiple childs. So suppose if there is any business process which has changed, and that changes the primary key of this particular table, then suppose if it is a owner's detail and then it is further related to family details like this. So all these keys has to be because this particular primary key would be working as a foreign key here. So you can understand the kind of changes you have to do if you have to introduce any small change. This is just one example, and I'm not saying that it is not resolvable. Definitely it is. There are techniques to resolve it, but then it is not agile. It is very time consuming. It is painful. It causes a lot of inconsistency. Now, suppose if we want to turn it around and we want to change it to a dimensional model. So what we'll do, we'll analyze this, what can be qualified as a dimension, what can be qualified as a fact, and then we will create something like this which is famously called as a star schema. So this star schema would have a single fact table standing in the center, and all the dimensions would surround it, and this would have an aggregated view of what you want to report at. So suppose you want to have to understand what are the business requirements, and based on that you will design your fact. Usually it is at an aggregated level. So what we have done, we have made this particular rental fact table, and it is surrounded by all the dimensions are surrounding it. So all the dimensional attributes would be here. The primary keys would reside as a foreign key in this particular fact table for all the dimensions, and then all the figures which you have to calculate. Suppose you want to understand, there is a business query which asks how much is the overall rent collected from a specific city, and who is the highest rent earner as an owner in this city. All these questions can be answered through a very effective model, which is a dimensional model, and this is where this particular model is very good at reporting. So suppose you want to create some sort of reports, you want to do some analytics, business wants to derive inputs from this data model, then it is a very effective data model. But again, it also has certain challenges. So suppose you have created this data model and this has gone live in production, and all of a sudden there is a requirement. Business says, oh, I forgot to tell you that I also wanted to analyze that how many flats we have on rent at a particular pin code. So what happened? You created this dimension, but this dimension suppose was at a city level, and the data which you contain here is at that grain. So granularity means at what level your facts will be aggregated against your dimensions. Suppose I want to understand, if I say that the grain of this data model or this fact table rather is at a city level, then I do not have data to drill down and understand what is your total rent or total cost or any other measure below city hierarchy. So a city will have multiple pin codes. Okay, so now you have to drill down and you have to go to a lower grain. But for that, what options you have? Either you have to change this fact table, reload it with the new grain, which might have a risk that you might lose all your history in this fact table, or you might have to introduce a different fact table. So this fact table would have the same data but at a pin code grain. Now what impact it makes? You have to load two fact tables, you have to hit the same source systems twice, you have to maintain and make changes to this whole data model, your reports and everything. So it is not very agile, it is very painful, it takes a lot of time. Also there is a risk of losing history. So I gave you the examples of how we can define a data model or a data warehousing data modeling technique via 3 normal form or via a dimensional model and what challenges we have. Now we will understand this whole example with a concept of a data vault. So friends, let's not see this whole architecture first of all, because it might be overwhelming to start with. We'll break it down into small pieces and we'll understand it step by step. So what I have done is, the data model which we discussed, I have just restructured it as per data vault architecture concepts. So data vault has 3 main components which we have to understand. That is a hub, a satellite and a link. So whenever you see any table, forget about this for some time and consider one example of an employee table. So if you see this employee table, what you see here? You see an employee ID, a department ID, employee name, date of birth, salary and all other attributes. So basically what data vault does is, data vault breaks down this into different components. So the first component and the soul of a data vault is its hub. Hub is the business key. Business key is that column in your table which business can clearly identify with and relate with as far as the data is concerned. So for employee table, business can directly correlate with the employee ID and it can uniquely identify any employee in a company. That's why your employee ID will become your hub, which acts as a central focal point of your whole data vault, and similarly you will identify different hubs. Your employee ID will become a hub. So just remove everything from here. Okay, so this has become your hub, so you can call it as employee hub. Okay, now it links to a department hub. So this is department hub and it has department ID. So department ID is the business key for department hub, and the link between these two is the unique link which identifies a relationship, and that link will clearly identify a relationship between an employee and a department. And then the rest all attributes or the identifiers or the descriptors of this particular employee hub will fall under satellites. So it will have your name, your date of birth, salary, etc. And this will be your satellite. Just to understand 3 components, hub will be your business keys, links will be the relationships which you form between your 2 hubs, and the satellites will be the descriptor information, the attributes. Here. So what we have done, we have taken the owner as a hub and we have shown other satellites which contains the detail of that owner. So the owner details table which you were seeing in the third normal form can now come into this particular structure. Similarly, property, location, tenant and everything connects through this particular link. So this is an overview of the architecture. Let's quickly understand this architecture in a detail level. In this diagram, what I have done is I have gone to the next level of details of the data model which we drew in the last section. And what I have done, I have not taken all the hubs and all the links. I have only taken 2 hubs, 1 link and 1 satellite, so that you understand how the data is structured and how the data is stored. So first of all, we have defined 2 hubs. So one hub is owner and another hub is property, and we have linked these 2 hubs with a link underscore owner underscore property. So what we usually have in a hub is, you will have a hash key. So these hash keys would be generated based on the business key. So this is in this case owner ID is your business key. So you will have four main things in this particular hub: your hash key, your owner business key, and your load date time, when the load happened to this, and what is the resource, what is the record source. So suppose your owner hash key is 123, your actual business key is 8256, the load date is 1st of January 2020, and your source is SRC1. Similarly, on property side, we have the hash key, or you can just consider, if you are finding it difficult, just consider it as a surrogate key, which is a technical key. So your technical key is 456, your property ID, which is your business key, is P001, your load date time is 1st of January 2020, and again your source is SRC1. So what you are now doing is you are creating a link which will connect. So what will happen, there will be another surrogate key or a hash key generated based on the combination of these two business keys. So what it will have foreign keys. So this particular property ID, which is the business key here, would act as a foreign key here. So combining this, so FK plus FK, so these two combined together will generate a hash key, and that hash key would be the unique identifier for your link owner property component. So you can understand what I have tried doing here is, so 1, 2, 3 and 4, 5, 6. So your link has become 1, 2, 3, 4, 5, 6, which is a unique link. Your owner ID is 8256, your property ID is P001, load date is, again I have kept it 1st of January 2020. So in this way, what you have done, you have formed a link outside your hub. So regardless of what is going on in your hub, your relationships are intact within this component. Similarly, coming towards the satellite part. So what satellite has descriptions or attributes, you can say, for any hub. So one satellite can only be associated with one hub. That is a very important point. A link can also have its own satellite, but that we will not discuss for now. So what a satellite component would have, it would have the owner hash key and the business key and the load date time. Why the load date time? Because you can correlate the satellite component like SCD type 2 of a dimensional model. You must have worked on SCD type 2. This is your biggest data set. All the history, all the records, all the changes, all the change data capture is stored in your satellite. That's why you always need that timestamp to be maintained, so that there is no deletion which happens in a data vault. There will be only inserts. Okay, so there will be no deletes, updates, everything will be maintained, and there will be no deletion. Like whatever we have in the source will be there in the data vault. Again, an important point is we have a unique column and date time. In order to do this change data capture, you have to understand that when the previous record got obsolete and when the new record has come in. So 123010120, which is the date timestamp and the hash key, for example, and maybe the end date is also 1st of January 2020. So on 2nd of January, if any other record comes in, then it will be inserted and it will be identified as a unique record. So friends, this is just a glimpse of a data vault, how the data vault enables you for an agile data warehousing. Why it is agile? Because suppose if there is a business change, suppose there is a business process change, then you don't have to change your whole data model. So take for example, now the business asks that for the owner, we not only want his personal details, his age or his date of birth, we also want his taxation details. Now taxation details might be coming from another system for that particular owner. But what we can do here is we can create another satellite. So there can be another satellite for this owner which will have your taxation details. So all your keys will be maintained as it is, the new keys will get added here, and your relationship will also get intact. Okay, relationship. So whatever relationship changes will happen in your link component. Suppose your logic or your business keys changes. So suppose instead of A256, now your owner details are coming from another system and your keys have become from alphanumeric to integer. Take for example, it's just a random example. So that will impact your link component. So suppose there is a location hub, okay, and this location hub has a satellite for city, which has the location details as a city. And suppose now business asks to take the data at a pin code level, you can have another satellite which holds the data at pin code level. So what you are understanding here is, what is very clear here is that you can go and you can make quick changes into your data model and at a very quick time. So your data vault architecture is scalable, it is adaptable, and it is consistent. These are the very important properties of any data warehouse. Guys, to summarize, I have quickly built this overall architecture which can be used in a case where we are thinking or we are planning to use a data vault. As I said, data vault is a hybrid. It uses the best of both the worlds, but it is not a one-stop solution and it cannot be used for any reporting purposes. It is only there to store the data as far as the consistency is concerned, adaptability, agility from the source systems. But in order to get the data out to business and have faster reads, you have to eventually create your data models or your dimensional data models on your data marts, which will further feeds into the report. But as far as residing the data into the enterprise data warehouse is concerned, data vault, and especially data vault version 2.0 with more changes, has enabled us that we can do that with a lot of flexibility. So I think this video explained clearly what a data vault is, the concepts and the components. I hope you found it useful. So thank you so much, guys. Once again, I would request you to subscribe to my channel, hit the bell icon, and please give your feedback, your likes, because it motivates me a lot. Thank you so much.